Good morning, good afternoon, and good evening. We appreciate you guys taking the time out of your day to join us for the 10 things maintenance wants designers to know. My name is Greg Rosing. I'm the product training specialist here at Hunter Industries, and I have a few housekeeping items that I want to go over before we get started in this presentation. So first, this webinar is being recorded and will be posted on our YouTube site as well as our training site later on this week. I'll be monitoring questions as they come in. So if you have any questions, please drop them into that section labeled questions on your GoToWebinar control panel. There's a drop down, type it in. We'll address those questions and comments. If you haven't done so already, go to revitup.hunterindustries.com to check out our current promotion where you have the opportunity to earn coins for weekly challenges that can be redeemed for Hunter swag, Hunter apparel, and even some grand prize drawings. So really cool stuff there. And don't forget, we have an entire library of free online training at training.hunterindustries.com. That's our Hunter University page. So that's also where this presentation will be held after we are finished. Also, if you don't already, please subscribe to our YouTube channel, Hunter Industries, and click the little bell in the upper right-hand corner to get notifications on new content. A lot of content there already. So go check it out if you haven't already and start learning today. We have some Spanish stuff on there as well if you have anybody in your company that requires Spanish training. Now, that's all I got for housekeeping. So I'd like to introduce our presenters and panelists for today's webinar. First, we have Chris Rosink. He's the Southern California Spec Manager for Hunter Industries. He covers the San Diego and Riverside areas. He has a bachelor's degree in public administration from San Diego State University, and he worked at San Diego State as an irrigation and sports turf maintenance technician. And this is kind of where he started back when he was 12 years old, cutting lawns, grew a business, and about 18 years ago sold it and came to work for Hunter Industries. He helps with the QUEL program, the Qualified Water Efficient Landscaper program here in San Diego, and it's a nationwide certification program. So if you don't know about that, we'll put some more information at the end. And Nick Straube, our second presenter, specification manager here at Hunter Industries as well, covering the Orange County area. He's been with Hunter for 5.5 years, and prior to coming here, he worked 10 years in landscape architecture and worked for a few different designs throughout the SoCal market. He's managed projects ranging from single-family residential to multifamily residential, commercial, and public works. Nick's a licensed landscape architect, and his influence at Hunter can be seen throughout our specifier resources, which are located on the Hunter website under Professionals and Specifier Resources, just so you know. We have a couple of guests today that we're really happy to have here from Brightview Landscaping. We have Eric Santos, who's the Vice President of Irrigation Services. Eric has a degree in agricultural engineering from Cal Poly, San Luis Obispo, and has worked in the landscape industry since 1994. Eric provides technical training and support for Brightview's irrigation teams. And he's got a whole lot of accolades, pretty much every single one you can get from the IA. Brian Maynard, key regional account manager for Brightview Landscape as well, has been in the California landscape industry since 1981. Working with key accounts, Brian is able to work with clients in all areas of the landscape portfolio, from new install to renovation and landscape maintenance. So these guys are really well versed in the landscape maintenance world, and we're really happy to have them on the call. I'm going to let Chris take it away with the intro to this presentation. Chris, go ahead.
Yeah, thank you guys for joining us. We're very happy to have you today. I want to provide a brief overview on some of the things that we're going to touch on today. But the main reason why we're doing this and kind of what we're looking to get out of this is for designers of irrigation systems and landscape architects, who have a vision of what they want their projects to look like, and how we can set a goal to design landscapes that are going to thrive and become the places that we want to show our future generations. And I know it sounds kind of corny, and I'll be the first one to admit it, but it really is kind of the design intent meets reality. And we're going to touch on that. We've spent a lot of hours combining this information and kind of trying to chisel this down to something that is deliverable within hopefully an hour. And one of the things that we talked about is that irrigation design and a well-planned system, is really as good as the maintenance can be. So we want to talk about, Hunter's commitment to this. And I'm going to put a few slides up here that you can take a look at. But, Hunter has a commitment to sustainability and the responsible use of water resources. And, reliable irrigation start with good fundamental design that provide thorough detail to the contractors that might install them, and specifiers who choose high quality irrigation products by a manufacturer that can provide field support throughout the life of the project. Really understand that partnership between design, construction, installation, and maintenance. And I think that's what you're looking for in a manufacturer. So this is kind of touching on two different scopes here. I mean, we're in the California market mainly, which is a pretty developed market, and we really have a lot of new high performance landscapes, I would say, with sophisticated systems and enhanced plant material, and trying to kind of get an idea of what kind of maintenance professional needs to manage these types of landscapes versus a typical maybe a smaller mow and blow kind of operation. So one of our guests here today, Brightview, and companies like them provide professional account managers, certified water managers, irrigation technicians that are trained on the industry best practice. And from that, having the time with Eric and Brian prior to this call, these are the items that we're going to be reviewing today. So you've probably looked construction administration and auditing, as-built, controller charts, hydrozoning and plant selection being a really key portion of this from the landscape architect perspective, managing water windows, how that relates to system hydraulics, and then the delivery system. The delivery system, drip irrigation versus overhead irrigation, or different applications. Understanding the precip rates and basically how that might relate to our run times and our scheduling. We're going to touch on fertigation systems, controller selection, sensors, central control, and then finally we're going to round it out with maintenance standards and how to choose a certified professional. So with that, I'm going to turn it over to Nick Strabe, and I'd like him to kind of take us through construction administration from a landscape architect's perspective and move forward.
Thanks, Chris. Yeah, the role that Chris and I play is predominantly on the specification end, and our role between the design firms and the contractors is always changing. But it's so critically important to understand what's happening on the plans coming from our catalog through the designers and then making it out into the field. And so, the importance of construction administration and observation can't be stressed enough. As a designer, you often get lost in the design aesthetic and the materials data and metrics, as well as kind of the 2D world of the drawing, and you miss out on the understanding of the issues that arise essentially in the field. Issues of unforeseen underground utilities, value engineering, and so on. Those arrive knowing that you will need to meet essentially the certain criteria for independent audits and evaluations for final sign-offs. And so while considering these issues is extremely important, we want to make sure that the end goal protects the design, or the end product protects the design intent. And so when we think about that, we think about these turnover packages through this construction administration, and it's an ever-changing set of documents because new things are popping up, new technologies from the time they're released, going through onto the plans and then being installed. Questions or new installation tactics come up. So one thing that we're always asking, or I'm always trying to get feedback from guys like Eric and Brian on is what are you guys looking for essentially in an ideal turnover package and on your final punch list. So I'm going to throw it to Eric and see, Eric, what are you guys really looking for in that ideal turnover package during that construction administration process?
Yeah, thanks, Nick. So just to back up a little bit before I answer that question, for those of you who may not know, Brightview has 4 core divisions. There's a Brightview Landscape Development, Brightview Landscape Services, and that's the division which Brian and I work for. There's also Brightview Tree Company and Brightview Golf. And then under those 4 divisions, there's other subdivisions like our snow division and winter markets, tree care division, But our irrigation repair and water management services fall under our landscape services division, which so our approach is whatever project our development division is doing, and we also have a design group, whether it be a design group or Brightview development doing the installation on. The goal is to always try to turn those over to become Brightview Landscape Services customers. So the transition process is pretty important for us. We have a pretty in-depth irrigation inspection sheet that we typically use to run through the irrigation system when we take over a project, and that starts from the point of connection, then to the controller, then to each valve, and then to each emission device. So in our initial approach, we don't necessarily go to the drawings, and our role isn't so much, well, let's check to make sure this is designed properly or to make sure it was installed properly. We do the inspection first. We assess the coverage. Then when we do come across any deficiencies, we start to take a closer look at the drawings and check for maybe any oversights that may have occurred either on the design phase or during the installation process. But some of our Brightview branches do offer water auditing services, which is one of the MWELO requirements here in California. But we typically don't do water audits on systems that are installed by Brightview Landscape Development. So these are audits that we do for other installation contractors or other designers. But yeah, we do have a pretty thorough inspection process that really looks at, goes as granular as every single sprinkler, every single emission device.
That's a good overview there. And I know that when we finish up these projects, we have, typically we try and get as-built sets of plans, and it's important to verify the design, as you mentioned, basically on the plans as it was sent to you, and then also changes that have been made in the field due to unforeseen issues, whether they're underground utilities or something like that. So what, I guess, we've all seen our fair share of good and bad as-built plans, and Brian, I know that you and your teams out there see these quite frequently. What should the specifier be sure to be documenting and include in their as-built plans to help really maintenance down the line? Because the project, although it's installed and there's a 90-day maintenance, we're hoping that this thing maintains over the course of 5, 7, 10, 20 years. So.
Yeah, thank you. Yeah, I mean, in my career, I'm seeing stuff that was installed, really 40 years ago. And some of them I was around when they got installed. So some of that cardinal knowledge of what's in the ground helps. It's absolutely critical, to have as-builts that show all the devices. You've listed everything on here that we're looking for, and that's perfect, and we threw in another one just saying even it'd be nice to know the breaker that sends power to the controller or to fertilizer injectors. There's other things that support the system that, if we can have that shown day one, it's a great way for us to be able to find and troubleshoot later on without having to dig everything up.
Yeah, and that takes us. Oh, I'm sorry, Nick, go ahead.
No, I just, it's the importance of as-built drawings. They're great to have day one when you turn things over, but thinking about those down the line, do you find frequently that you'll inherit sites that necessarily don't have as-built attached to them?
Yeah, absolutely, we do.
Yeah, I think that kind of takes us into the next thing. I mean, the controller chart, just knowing where the stations are to be able to turn on the controller. Sometimes you'll see the wadded up piece of paper, maybe it's in English or Spanish, it's written out, with some basic information, but the moment the wind blows and that door stays open, that's gone, right? So what are you guys looking for? Brian, what are you looking for as a minimum standard for your controller schedule charts?
I think if you're showing here a color chart that would be laminated, it'd be nice to have, a laminated one in the folder and then also, or in the controller, and then also for us to have an electronic copy that we can keep in our system so that forever, as we move people to that, that image can stay and we can continue to use that. And then the legend is essential too. You know, that typed out legend you show there is absolutely perfect. We would love to have those in every controller.
Now, another thing that was brought up in our call the other day is what happens if you show up to a site and you're taking over maintenance from somebody and they don't have any more of these native documents? You know, somebody had to design it because the county standards require you to have a set of plans. What can you do? Is there, you know, can we put a sticker in the controller like some of the aftermarket manufacturers do that tells you, you know, who designs it, who was the installer? Maybe you could go back and reference, but you know, what would you actually go back to a landscape architect and request these documents?
Absolutely. You know, I have, and it's much easier to get them through people you know than to try to go to the city and track down documents. But yeah, I love that sticker idea in there. I think that would, you know, those stickers would stay in there.
Yeah. And is it unrealistic? I'm just thinking outside the box here, but is it unrealistic that a landscape architect driving by a project that they know they did, that's their baby, they want to see those trees grow, and they notice that the maintenance company's changed? Is it unrealistic for them to stop by and say, hey, if you guys need the, you know, documents on this, we're happy to help, or, you know, provide them, you know, maybe even engage themselves in the project again if there's maybe a renovation down the road? Is that something specifiers could do?
Absolutely, and I know locally here in our market we have had that where we've reached out knowing that they did it, and then in the same way where they've noticed we've taken over the maintenance and they had originally designed it.
Yeah, it's just good. I think it's good to try and think outside the box because we're all in this projects together, and a lot gets lost in, you know, communication or lack of communication once projects turn over to maintenance down the road. So that's a big, I think being proactive in that might be approachable to a maintenance contractor. So Nick, you're going to take us through plant selection and hydrozoning.
Real quick there, I think, Eric, did you have something to say on that? I thought that I'd heard you trying to get in there.
Add on to what Chris said. You know, for any landscape maintenance contractor to manage irrigation effectively, they need that controller map. And 99% of the time when a project gets turned over between maintenance contractors, that map disappears. So I think a good maintenance contractor, one of the first things they do is if those maps don't exist, then we create them. And if we're able to find out who the irrigation designer was, man, it's almost like winning the lottery in our world. You know, we know who to reach out to for all this information. We don't have to recreate it. So it is a big help. And the idea of having a sticker of who designed the system inside the controller door is an awesome idea.
Good point. Really good point. So yeah, you know, our next point here is hydrozoning, and I think we're getting pretty close to all being familiar with it. But you know, for those that aren't, hydrozoning is, you know, the practice of clustering or grouping together plants with similar water requirements in an effort for essentially water conservation. And you know, there's such a high level of importance placed on plant selection as planting is a defining aspect of the project. Oftentimes, you know, specifiers can get lost in the materials and lose track essentially of what the water needs are, and for the various plants. And you know, in the past 5 to 7 years or so in our market here in Southern California, there's been more emphasis on essentially water conservation and our model water efficient landscape ordinance. And so more importantly more important than ever before, we're seeing, you know, hydrozoning charts come out on the front end design development. And so, but how does that translate really to the field? So, you know, with that in mind, you know, what do you guys see? And Brian, you know, how are specifiers addressing hydrozoning out in the field? Is it successful? What's happening on the plans and getting their plant pallets out into the field to match up the site conditions?
Yeah, thanks, Nick. As you know, as we've taken over a lot of projects, you know, I mean, probably one of the easiest ones to fix is the, you know, sun and shade on the same system. Definitely that plant material is not going to need the same water. And so if we have those areas separated, then it's a no-brainer. Turf and shrubs should not be on the same systems, you know, so those are separated. But then, you know, as we've gone to in our market to a more drought tolerant plant material, you know, some of the succulent materials have not done well on drip, you know, in certain situations where the shrubs that they're next to need a lot more water. And so in some of those cases, we've seen that performance-wise, that overhead spray actually is working better in those situations.
So really, it's about matching your plant palette to the delivery system and considering that as well.
Absolutely.
Interesting. I know that, you know, when I go out to the field sometimes to help the contractor with some issues, some of the things that I'll see is I'll see plants that I know are properly hydrozoned, and they're burnt up, and you know, you're sitting out there for about 5 minutes, you're scratching your head as to what the issue might be, and then you realize that the office building across the street with the reflective windows at 12:30 on July 14th through the 31st is reflecting heat and burning up the landscape. And so, you know, I think those are also key issues to see out there is get out of that 2D and be on site. And this goes back to your construction administration, getting out and seeing what the actual changes are in the site while it's being built. So those are some key things to see there. And you know, plants that work with your irrigation are huge. And talk about, I guess, plant performance and how it does relate to irrigation.
Yeah, you know, I like what you mentioned there about the glass. We see that in a lot of hospitality sites where the sun, you know, they're built along the coast, and when the sun hits just right, it hits the glass on the building and comes right back down and burns up the landscape. Some of those cases, you know, are just going to happen. You're going to have to, there's, you know, that's really so far out there on the design, trying to figure that out. But low areas, bioswales, you know, that type of stuff, making sure you have irrigation that really works for those areas. And the other one is that we've seen in our market is if it's all drip, that we have had to go through and then certain parts of the summer syringe things off, you know, with water just to clean them off. So those are things that we've been, you know, having to deal with from a maintenance standpoint.
Yeah, Brian, you know, I can kind of go back to an experience that we shared together where a specifier, a landscape architect, actually invited us both out to a site out at Torrey Pines Corporate Park. And again, like you said, out on the coast, and they kind of, the goal with our meeting was to kind of reverse engineer a plant palette for the renovation of that site. And they had asked us to look at the delivery system and how plants were performing with the reclaimed water and the high salinity that we had there. And we kind of looked at the different delivery solutions that would best match the plant material that you guys were finding worked in the area, that would give the client in a very high-end, you know, amenity-rich business park the look that they were looking for. And then the specifier walked away, I believe, with a peace of mind that we had a good plan together. We kind of reverse engineering it that way too on a renovation site. Yeah, that was pretty cool.
Absolutely.
Okay, and we also touched on drought tolerant plant material. By the way, the WCOLS database, WCOLS, is a great database of plant material that you can use. It is what the state of California references, the Department of Water Resources references for water use efficiency on high, medium, low water plant material. So something to look at if you're not familiar with that. Let's talk about water windows. And you know, one of the things that yeah, I'm gonna let Nick take this one, but this is one of the biggest things that we see on maintenance. So Nick, take it away.
Real quick, Chris, I want to circle back to go back 2 slides to you talked about salinity and reclaimed water, and oftentimes, you know, we're designing irrigation systems for potential future reclaimed water, and so it's domestic to start, and some of those selections of those plant materials are based on your domestic line and what's going to survive well off of that. But keeping in mind the plants that will survive or will thrive when you do make a switch and go to a reclaimed situation, it is also something that's of high importance. And you know, I don't know what you guys see in the field, Eric and Brian. Do you see mishaps with that while you're out there?
Yeah, I mean, a lot of issues that I see are systems that weren't initially designed to be on recycled water, and I just think the trend right now is if the system's not on recycled water, you know, sometime within the next 10 years, it probably will be. So just keeping that in mind, both on the plant pallet side and both on the irrigation hardware side.
Okay, good points there. So yeah, to get into water windows, the water window is the time of irrigation, the total time. It's not, the time that station one takes to run. It's from station one through whatever for that program for that day. And so we start thinking about water windows, and it's always varying depending on some adjustments. And so can you discuss, Eric, some of the challenges your team's experienced meeting water windows out in the field?
Yeah, water windows are a big challenge for maintenance contractors, and oftentimes our properties, they're large commercial corporate campuses. Like the Apple campus was one. You have a lot of valves and a limited water supply, and we typically have multiple controllers drawing off of one single water source. So when we have a typical water window, that maybe our water window opens up at either 9 p.m. or 10 p.m. and then it ends at 6 a.m. So we roughly have 8 hours to try to get the watering done in that nighttime window. And then if you add in the fact that we try not to water during the weekends, just to prevent any mishaps from occurring over the weekend with stuck valves or mainline breaks. And then on top of that, we try not to water either 1 or 2 days before the site's going to get mowed. What we end up with is 4 nights of watering where we need to try to get our watering done within 8 hours. So the first scenario we have is when a site has limited pressure. And we need to make sure that we don't have an excessive number of clocks running simultaneously, and we end up overtaxing the system and our available pressure. But then on the other side, the other scenario is when we do have plenty of pressure and we're in this tight water window, the concern then becomes of just us being careful not to make sure that we're running too many controllers simultaneously, where we end up exceeding water velocities of 5 feet per second and end up having excessive water hammer, and then that resulting in an excessive number of mainline breaks. So, I mean, water windows are a challenge in what we do. And I guess if you go back to the design, it'd be nice if we could water 7 days a week, 24 hours a day, but within those windows, we have to figure out how to run the system at the right flows.
Good point there. So when is the most critical demand on your system? I guess typically, I know site specific might be site specific, but just typically.
Yeah, well, one is during establishment, when plant material goes in and we're in that, after a new project goes in, 90 days is pretty critical. But if those 90 days do happen to land and coincide with, July's our peak ET season, but temperatures still feel warm from August, maybe even to September. And you'll find that peak irrigation schedule will tend to carry over from July all the way through mid-September. So if we're in a situation where we have new plant material and we're trying to establish it, and then we run up against maybe, if we're in a scenario where we do have watering day restrictions, it just becomes even more and more challenging to try to get that water down. And we can try to be creative with running drip or bubblers during the day, but then you have cities that have automated meter reading devices where if we're watering outside of those watering day restrictions or those water windows, then we get emailed that we're violating the watering day restriction. So, but that's an extreme situation. But I guess the best approach is getting back to the fact, don't assume that you're always going to have 7 days to apply that water in 24 hours. You may only have 4 days a week, and out of those 4 days a week, you may only be able to water 8 hours per night to get that water down.
Those are good points there, and I think Chris, you can go back one. It gets to the point of it's almost a full-time job to water manage essentially every site. So, I know here we're showing kind of a program summary, and this is with our ACC2 clock. And what's great about technologies like this is that we can essentially put in our ranges of flows, and as one station might be dropping off and finishing up, it can just go ahead and meet that range of flow and keep adding, so then that way we can meet those water windows. So I think when you see those types of technologies or options out there, it's important to capitalize on those just for the ease of maintenance and you guys hitting your water windows. So it's good stuff there.
You know, and I think system hydraulics really ties right along with water windows. Is how much available water do you have in your system? What's your design capacity? And what's your peak season demand? I think there's often a trade-off at the beginning of projects on design as to, you know, how many water meters we're going to get or what size we can get with our developer rep, you know, pushing back on initial cost of setting a larger water meter. Maybe you have to use multiple smaller meters. You know, maybe it's the cost in perpetuity of a meter access fee. So there's a lot of things to think about, and we did a point of connection webinar that touched on this significantly. But you might be pulling out of a lake or some sort of other water source. How do you know that your site, your source is big enough? So Eric, just another one for you. I mean, when is your peak flow? You talked about peak demand when on your controller. What's your peak flow in a system? Can you describe that?
Yeah, you know, that's a great point, Chris. I mean, you almost have to assume worst case scenario because I guess with landscape contractors, if there's any remote possibility of something going wrong, it actually will go wrong. So if you look at the highest flow rates possible on each controller, and it's not completely out of the question that a contractor will run multiple high flow on all the controllers on the site all at the same time. So I guess if you look at maybe you take each controller and you look at the top 2 or 3 of your high flow zones and then assume that there is a possibility that those zones can run concurrently with multiple controllers. Yeah, that's kind of the situation that a contractor will actually put a system through. So yeah, I guess worst case scenario is very likely in a contractor's world.
Yeah, it really talks about the demand for you guys to have to overlap programs to kind of get through your water window. And then you were going to touch just briefly on water quality and filtration and what you guys are experiencing out there.
Yeah, I mean, with water quality and filtration and just pressure, as a matter of fact, when you know, whether it be from local development that occurs in the area or water restrictions, which force everyone to water at the exact same time, or something that's out is water districts reducing incoming pressures as a way to indirectly lower consumption. You always have to be careful not to design a system and stretch it to the maximum of its capabilities. And you know, system filtration is a big concern as well. You know, knowing your water quality, where you're drawing water from. You know, if your water is you know, excessively dirty, you're going to have that filter that's constantly flushing, which is going to impact your water window as well. If you're using a filter that goes into an automatic flush cycle, that's additional time that your system's going to be down.
Yeah, and again, clogged filter affects your pressure. You know, the pressure is probably one of the biggest things, you know, in the system. A good rule of thumb, I think, to design with, as we touched on that last slide, is determine your critical demand, your worst case zone, and then design to 80% of what you need. So if you have a critical demand, give yourself an extra 20% cushion over that, because, you know, just like Eric's going to talk about a little bit more here, I mean, things are going to change over time. So how do you guys check your pressure on a system, and what does a pressure test look like?
Yeah, I know initially during construction, a design will say that the system's designed to provide, you know, X amount of pressure at so many gallons per minute, and contractor to verify. But you know, after that job is installed and that pressure is verified, it is very common for those for pressure. And typically the most common reason is for development in a local area. As development increases, pressure is going to decrease. So Yeah, I really like the idea that you guys shared earlier, Brian or Chris mentioned it, of having that sticker inside of the controller that says who the system was designed by. Maybe another piece of that information, which I would find really valuable, is knowing what the incoming pressure was supposed to be when the system was designed, because gradually over time, we do find that pressure does decrease. And if you're using a system that has flow sensing, the decrease in pressure is going to completely throw off your flows from season to season. So if you are if you do believe that pressure has decreased, it's probably going to be a good practice to start checking flows at the beginning of each irrigation season, checking pressure, and then if the pressure is decreasing, going through after you do a full system check and make sure everything's running properly, doing a complete learn flow on all your zones again.
Yeah, another thing out here in California, because of the topography we have and some of the pumping systems, we tend to have higher pressure from domestic lines or fluctuating pressure in recycled water systems as the pump demand changes. One of the things that when I've walked the sites with maintenance contractors, the number one thing that comes to mind is just the pressure is too high on everything. And what happens when that is? I mean, one of you guys, I think, mentioned that it's just an absolute passive water savings, a pressure regulator. But it saves wear and tear on the system down the road. But how do I know if I need a pressure regulator? What's my indicators, and where would I put it in the main line?
Yeah, I mean, for me, my kind of rule of thumb is if I'm coming into a system that doesn't have any rotors on it, and let's say all the irrigation is done with either sprays or drip, if the incoming pressure is above 75 psi, I typically like to see a pressure regulator at the POC. In some cases with really high pressures, it isn't very common, but we do have sites that have incoming pressures of 300 psi. In those situations, we need to have 2 pressure regulators installed in series. But yeah, typically if the pressure is above 75 psi, having a pressure regulator at the point of connection is a great thing to have in place.
Okay, so moving on, next question here. Pressure regulation at the valve or pressure regulation at the head? What's your take? Both.
Yeah,
or
yeah.
both?
Good point. In theory, having pressure regulation at the head is ideal, but one thing to remember is pressure regulation at the head wears out over time, and sometimes you'll find contractors using non-pressure regulated heads as replacements, which for those of us who are in California later this year actually won't be a problem when pressure regulated heads are mandated. But pressure regulators in the sprinkler head start to drift out over time as they wear out. And I guess so I'm an advocate of having it both at the valve and at the head. I love regulators that can be added right to the valve, like the AccuSync regulator. And the only time that these do become an issue that I see in the field is when the valve isn't sized properly. And we see this sometimes on valves that were initially designed to be spray heads, and then those valves get changed over to MP rotators or converted over to drip. And then we start to see that the valve with the regulator doesn't function properly. But that's really not so much an issue with the regulator, it's more so an issue with the flow and sizing the valve properly. But yeah, having them both from my perspective, and just to remember, all regulators on spray heads aren't the same. If you're using rotary nozzles, you might need to use a head with a different PSI regulation on it. But yeah, so I guess to recap, if you're above 75 PSI, you should have one at the POC. And then having it at the valve is an added plus, but having it in the sprinkler body is probably the best place to have it.
Yeah, yeah. So for overhead systems, the 30 PSI for spray heads typically, and about 40 PSI was optimal for an MP rotator. So different manufacturers may have different requirements, but that's pretty much by and large what we go with. Now, Nick, you were going to touch on booster pumps. We had a long conversation on this, and in the interest of time, we're probably not going to be able to go too far into this, but did you want to touch on that, Nick?
Yeah, good point, Chris. You know, last week we had a webinar on the point of connection, and that's where we really dove into booster pumps and the need for it. We had Daryl Green with Green Product Sales on to kind of break it down and give us the details. As they get pretty complicated, but the key takeaway today is if you need a pump, spec a pump, and don't think you're really doing your client a favor by designing their system at capacity or by making any changes for them to not have a pump. And to Eric's point a few minutes ago is think about the longevity of the project. Think about it down the line. Phase 1 is what you're working on, and someone else might be coming in to work on phase 2. The pump might be needed for phase 4, right? By the time you start looking at the entire site. So what comes down to oftentimes is value engineering, and they say, oh, it's a big ticket item and a big cost, so we're just going to get rid of it. But your system's going to suffer, and you know you could potentially be losing plant material, you could be losing landscape that will eventually exceed the cost of the pump. So if a pump's typically on a plan, it's on a plan for a reason. And so, like I say, putting it in on the front end of the plans and sticking to it and holding your ground on it is always a plus rather than letting it off. Because nobody wants to be hit with that $20,000 change order at the back end of development here saying we need a pump. So if you need one, spec one.
Yeah, that's our soapbox on pumps. I'm sure you've all heard it many times from us, particularly with sports field rotor systems. VFD pumps being a little bit more efficient and being able to change with fluctuations in the mainline pressure, very good. And we've all been in the situation where the pump goes down midsummer, we don't know who to call. Local pump providers tend to be the go-to because they usually can be the first responders come out and help out, get your system back up and running. And that was just some of the cliff notes of what we talked about there. I'm talking about drip system maintenance now. And I wanted to let Nick touch on this and some of our favorite topics around drip irrigation.
You know, we always come into this question of different types of delivery, and is drip better for this, or is overhead better for this, or what are your thoughts? What's your approach? And you know, there's a right place for everything, for each delivery system, and you know, the thing to consider, and the thing I think that isn't considered oftentimes on the design end, is the maintenance of these variable systems, whether it's overhead or drip. So, you know, I'm going to kick this to Eric here is, you know, maintenance of a drip system. Any special requirements when you guys get onto a site? You know, what's kind of your checklist, or what are you seeing? And when you see 40 stations of drip on a site, is it, you know, what are you guys thinking?
Yeah, it's you know, I think if you ask most contractors, it's definitely something that they know their work's cut out for them. But you know, if you look at markets like Las Vegas, I mean, drip is the normal there. And you know, 20 years ago when drip started to be used, you know, a lot of those contractors out in Las Vegas dreaded taking over projects with drip. But you know, drip is extremely much more efficient than overhead, but it does bring its own separate set of challenges. You know, we strongly encourage, you know, when we take over a project, let's go through that with a fine-tooth comb. You know, depending on the kind of drip, from a maintenance perspective, we want to make sure that we have flush valves installed properly, air relief valves if the drip system doesn't have built-in check valves to it, pressure regulation, filtration, and you know, since drip is going to be buried most of the times, it does take extra time to go through, but it really is within a landscape maintenance contractor's best interest to spend the time to make sure it was designed and installed properly.
Nice. And Brian, you touched on a little bit in the hydro zoning, but can you just touch on plant performance? Just recircle back on plant performance and drip versus overhead and that kind of stuff.
You know, a lot of the the slide that's showing there, the different types of systems. We much prefer the inline drip system laid on the surface, attached down, and then covered with some sort of material. Most of our planters, at some point, somebody's walking through from the general public, and so it ends up that anything sticking up, they're kicking or breaking. So I think in general, as we see it, really the inline is kind of the one that we prefer.
You're seeing the best results typically from that inline. That's good. Okay. And how are your thoughts? And you talked about drip on grade here covered up. What are your thoughts about drip on slope? I guess this is for the group. Eric, Brian.
Yeah, drip on slope, you always got to remember that water flows downhill. So oftentimes we'll see point source emitters on the down slope side of a plant, or even with inline drip tubing, when that's installed across a slope, if you have plants that are spaced out on 30-inch on-center spacings, but you're using drip tubing that has emitters that are spaced out every 18 inches, you may have a plant that ends up directly between those two emitters, and if water's flowing downhill, that water is never going to make it over to the plant that's 9 inches away. But on the other side, if that plant ends up being directly below the emitter, that plant's going to get completely saturated. So definitely on slopes, think about spacing of your plants and your emitter spacing on your inline drip tubing.
So takeaway on this, Eric and Brian, point source or inline wetted area?
Yeah,
I'd say inline. For me,
yeah,
inline.
I agree.
And again, I think this is based on your plant density. How far apart your plants are. Desert regions, you might see a lot of point source there. And but anyway, the other thing is, how do you know it's on? How do you know it's working when you're doing maintenance checks?
Well, if you've got, we talked about having the indicators, oh, there it is. So, in these two scenarios you're showing here, one under mulch, it's easy to find tubing. You got to dig around a little bit. But boy, when you get into decomposed granite or rock like we have here, it's much nicer to have an indicator that shows us it's running instead of having to dig up stuff.
A great point to the indicators you're showing here, Chris, is that you can attach a pressure gauge to it, and this is really going to help your field guys, get an idea as to if everything's pressurized, if there's any breaks in the line, even though the indicator's popping up saying, hey, we're good.
Yeah, and these indicators have springs in the actual device so that it only pops up if it has 12 psi, which is pretty close to what you need to fire a drip emitter. So if these aren't popping up all the way, you've got a service call ahead of you. And to Eric's point, I think it's always good to document your pressure at the time of installation so you can evaluate what's happening in your system. Is your pressure decreasing? Maybe you've got some line breaks, or is your pressure increasing and maybe you have some plugged emitters? So these also can be used as flush mechanisms too, because you can remove the nozzle and flush out any debris either by completely removing it or putting a nozzle flush plug that you might have, like for a spray head, to flush out the system. So, and guys, we are just running a little bit behind, so we're going to have to move forward a little quickly. Precip rates, and I'm going to take this one as far as it relates to your soil. And you can't have a conversation about irrigation without talking about soil and water management, moisture management of the soil. Obviously, soil preparation is key. I know most specifiers I talk to are really encouraging good soil reports and then testing and getting the right amendments in. But maintenance is only as good as the soil. I remember running my maintenance company. If I had compacted hard soil, it was a nightmare to try and get water into it in peak summer. So the heavier your soil, the more you need to consider what your precipitation rate device might be and match your application rate to your soil intake rate. And this one's for Eric. Eric, do you want to touch on what we got up here?
Yeah, this goes back to having that sticker in the controller. If there was something else, another piece of information I could add to that sticker, it would be to add in the, for inline drip tubing, what the row spacing, emitter spacing, and the flow rate is on that drip tubing on each zone, because typically you might see in California on heavy clay soils, you'll see the system may have been spec'd at 18 by 18, utilizing a 0.6 gallon per hour emitter, but somewhere along the line, the contractor ended up putting in drip tubing at a 12 by 12 spacing with a 1 gallon per hour emitter. And if you look at the precip rates on those, they're completely different. And yeah, I think I see more plant material lost from overwatering with drip than underwatering. A lot of contractors out there just think, hey, I need to run drip for 60 minutes. That's kind of my rule of thumb. Sprays for 10, rotors for 30, and drip for 60. Doesn't matter what the precip rate is. And for me, that's a pet peeve. If I take over a project and it has inline drip, that's one of the first things I need to look into is what's my row spacing, emitter spacing, and emitter flow rate. Because without that information, I'm not going to be able to manage my water properly.
Yeah, I mean, you're really flying blind trying to figure out what your runtime is going to be and or what your application rate you're going to put into your controller. So you had really touched on the importance of manufacturer's charts, Eric, when you're choosing any irrigation device. And Brian, I know this is one that you had touched on, which was the nozzle selection. And I know your group was big on this as we were prepping for this call. Matching precipitation rates and matching your nozzles so that they're balanced and evenly watering your area. You touched on the head-to-head coverage of sprinklers, which is pretty much design 101. But what about the difference between rotating nozzles, sprays, and rotors? Can you touch on that just for a minute, Brian?
Yeah, Chris, I think the big one is we talked about is they can't mix them in the same zone. You know, that you really have to have a separate valve for each of those products. As we take over older sites, it's crazy to see in time what people have done, you know, even running down to the local hardware store and getting heads and popping them in. And really, you know, you need to be going through those systems all the time to make sure you have matched manufacturer, you know, type, so that you know, looking at the charts, you're getting the right amount of water and not having to come back out and supplement with hose water or overwater the whole system because you have one area that's not getting enough water.
Yeah, you always have to water to that dry spot. So whatever the slowest performing nozzle is, or the missing overlap in coverage is what you're going to have to water to. So it was a really good point. I think this is basic knowledge for most people. But again, like trying to mix rotors and MP rotators and stuff, I mean, you kind of get into a mixed bag there, and it might look good on paper. It might be easy to design on paper that way because a rotor and an MP rotator tend to have a pretty close precipitation rate relative to a spray head. But you know, mixing and matching it could lead to problems down the road in the field. Another one. This is one of the big ones, at least here in California. The local ordinances are requiring bubblers for establishment watering, and the model water efficient landscape ordinance is part of the building code now. So you have to have a dedicated irrigation system for trees, and that might help out in a drought scenario if you needed to kind of go back to watering of trees and taking out other ornamental landscape, turning that off to conserve water. What's your guys' take on tree watering? We got 3 different ways here: bubblers, above grade, drip rings, and then in grade bubblers. What do you guys like? What are you seeing?
You know, looking at these 3, you know, these images, I prefer the 2 on the right where you've got water going over the top of the root ball compared to just the one on the left where you have a tube that water goes down. You know, sometimes we've had problems with trees not establishing because we literally are only getting water in one column, and the rest of the root ball kind of suffers. So in my preference, I would rather have it where you get across the top of the root ball with the water.
Yeah, Chris, I'm an advocate of having a system that could be expanded as a tree matures. So that's one of the reasons I like drip rings, is we can add on to those, keep the water at the drip line and maybe a little bit further beyond that. But yeah, I am not a fan of the deeper watering tubes. They may work well for establishment, but once the tree is 3, 5 seasons later, kind of think they're a waste of water.
Yeah, that's a good point. Is you know, you're putting water right at that fluffy root ball, trying to get that established. It really is a good establishment system, but how are you going to water the drip line as the tree matures? It's something to think about. We do see people taking the root zone watering systems and converting them over to like some sort of a micro spray that'll throw, you know, away from the root ball, you know, over time. And so maturity versus establishment, it's really important that these establishment systems get turned off after the trees start to mature so we don't overwater. All right, guys, fertigation systems. Nick, we're running short on time here, but I want to give these guys a chance to give them a shout out.
Yeah, so if you go back to our webinar again last week, it was part of the point of connection, the fertigation system coming right after your flow sensor. And the importance of fertigation is undervalued. I mean, people are this is another point of the system that people are saying, hey, we can value engineer it, take it off the plans, but I'd encourage you to think about how you're actually fertilizing your drip zones. And if you think that it's happening with granular fertilizers, there's nothing overhead that's breaking it down. And no matter how good the maintenance performance spec is to come in and hand water down granular fertilizers, it's not really happening. So to promote, you know, great plant health, we want to be looking at keeping those fertigation systems on our plans. And every time your system's turning on, essentially giving a micro dose of nutrients to your plants. But you also got to factor in sizing that system to your landscape. And, you know, I think that that's also important. That's a large footprint, and or there's a schedule that's associated with that to keep adding fertilizer to the tank. So what do you guys see out there in the field with regards to maintenance of these? Are you seeing projects that were slated to go in with fertigation and that gets taken off, and you've seen your plants, your landscape suffer? I mean,
Yeah, no, I think you covered it pretty well, Nick. You know, with drip, I mean, there's really no other way for a landscape maintenance contractor to fertilize. But just one thing to keep in mind, if there's a tank that's installed at the point of connection, what you're fertigating, you're actually applying that fertilizer to all your zones. You can try to run certain zones at specific times, so you're only applying what's in the tank during that period. But yeah, it's kind of, if you have a tank at the point of connection and it's something with a basic tank like we have in this picture, you end up applying that. Typically, it's across all zones uniformly.
you know, good points there. And one thing that's important to note is checking on your plumbing code when you're thinking about throwing in a fertigation system. You are going to need some backflow prevention based on your different codes, so that way you aren't pulling any fertilizer back in through your system. So that's always best practice there too. But good points.
And Brian, you had mentioned you guys typically see these on the retail and, you know, hospitality commercial spaces where you got to keep the plants, you know, looking their best and keep them juiced up like the nurseries deliver them, right?
No, we do. And the other one is, you know, not doing granular in our market too. You know, they don't want anything on the asphalt or on sidewalks, you know, no runoff. So having a drip system or having something that goes through the system so we don't have granular on the ground certainly helps.
Yeah, that's a good point. And anything to reduce any kind of you know, runoff or environmental pollution from our sites, I think that's a responsible thing for maintenance to consider. When we talk about, you know, the control system, as we kind of wind down here, this could be its own webinar in and of itself. Just how to choose a control system to meet your water windows, something that's intuitive for the user interface. Again, we talked about different classes of maintenance professionals. You've got your certified water managers and people that really understand applying inches of water over a landscape and depletion and things like that. Then you've got basic, users that are struggling to put the right schedule on the clock, and that exists in the world. So it is important to know, are you going to have a premier maintenance contractor, or is it likely to be a lower budget site that may can just afford somebody to come in and service the grounds and maybe update the controller? So we look at that through the lens of choosing a conventional control system versus a decoder system, which Eric's going to touch on in a minute. All the programs and horsepower we need to run the stations simultaneously to meet our water window, and flow management features that the controller can kind of go into cruise control and set a target flow. We talked about we're talking about maintenance remotes just briefly, because I think that's an important one. And then Eric, you wanted to touch on master valves and compatibility of master valves from the designer's perspective with the controller. Can you touch on that real quick?
Yeah, that's one thing I surprisingly see a lot when I do MWELO audits for other contractors, and it just seems like everybody tends to miss this, where they'll have a normally open master valve spec'd out, but the controller won't have the capability to run a normally open master valve. So what the contractor does, they just don't connect the master valve up, and when they do, they find out that the normally open master valve actually closes on them when they run water. So just something to keep in mind.
Yep, and then two-wire versus conventional systems. Do you want to talk about just some of the benefits of two-wire and some of the concerns that you guys come into out in the field with two-wire systems?
Yeah, I mean, they're just huge labor savings when it comes to the installation side. So this is another thing that I tell people within our organization. Your initial sentiment is probably like, oh yeah, this is going to make my life a whole lot more difficult, but it's just like anything else that's new. It may be a little intimidating at first, but once you get to understand it, and if you have manufacturer training and support, I think most people find that as a maintenance contractor, two-wire actually makes your life easier. The troubleshooting is just way easier on a two-wire system once you have the right tools and once you have the knowledge. In comparison to, that's a great picture you have there with the bundle of wires. That looking at that's very intimidating. When I look at the two-wire, it's like, okay, now it's going to be a lot more easier for me to troubleshoot the system.
Yeah, and I think a lot of times one of the things that we get into is in the heat of the system or heat of the season, if that wire is compromised and you do lose part of your system, what are the challenges you see? What are the things that you typically see as being the culprits in a two-wire troubleshoot?
Yeah, we really try to stress this to our people when they take over a system. Again, here, if it's two-wire, you need to go through it with a fine-tooth comb. Make sure you have the right wire connectors, the proper wire, and the proper grounding. Because if you don't have those in place, those might be issues that may not come up until 6 to 12 months after you've been on the project. And it's really difficult for you to go back to the customer and have that conversation of, yeah, hey, grounding wasn't used, and now we have mass numbers of decoders that are failing, and I can go through and replace those decoders today, come back next week and have 2 or 3 more decoders bad if I don't have grounding in place. So again, it's really, really important that it be installed per specification.
That's a great point, Eric. And it saves the manufacturers a lot of hassle too, because everybody wants to point to the name on the box, and every manufacturer is going to have similar situations, because it's like, if a main line breaks, they don't call Hunter and say, hey, your system stinks because it says Hunter on the controller. They know that it's a hydraulic situation. If your two-wire path goes out, they think, oh no, the controller's not working. So Nick, what are some good things that specifiers can put in their plans on design notes, installation details, and legends to help mitigate that?
Yeah, Chris, as I was talking about early on, is that plan packages keep changing and they evolve over time, and we learn, best practices by some failures. And so what we've done is we've kind of compiled, I think it's about 17 or 18 points now on our two-wire controller list to ensure that when it's being installed properly, clean, and concise. So then that way, if there is any troubleshooting necessary out in the field, then you can it's easily noted on the plan. You can find your way back to it. So it's really about identification, color coding, and really just being super organized. Think of it as kind of like a file cabinet, and just if you have good folders or labeled properly, then everything's going to be easy to find and troubleshoot. And to the point on the last slide about being out in the field, if you have let's say you designed a certain station valve to go to whatever your flow, your capacity is, and something happens out in the field and you needed to add a second valve and split that valve up, being a 2-wire system, it's easier to add. You don't have to get your way back to the box. And so I just think about that from the maintenance side, is that they can sit there, they can troubleshoot, they can keep those costs, to a minimum, as opposed to having to rip up, concrete or asphalt and that kind of stuff. So what I'm saying here is we have some great notes. If you go onto our Hunter Industries website and go into our specifier tools, there's some legends for 2-wire controllers and 2-wire projects, and that's where you're going to find our notes.
And Greg will touch on a webinar that we did recently, specifically on 2-wire do's and don'ts, and that goes a lot further. Again, touching back on flow management, just kind of wanted to round it out, the importance of using controllers with modern technology, being able to set flow targets so that your main line can operate efficiently, make sure your pump is running more efficiently. Not every controller is the same out there, and just controllers that say that they flow sense and do some sort of a detection doesn't necessarily mean that they can manage a main line and hydraulics of a main line within a given flow. So knowing what your station flow level is, being able to read that, we see a lot of discrepancies in the zone between high flows for your target total flow and then your low flow drip zones that may be 2 gallons a minute or maybe even less, and you need to know what the flow is for that station. So sizing your flow sensor is very critical, and that's another conversation in and of itself, but check with your manufacturer's specifications for sizing your flow sensor. And Eric, I'd love for you to touch on the importance of flow and how BrightView is using flow these days to monitor systems.
Yeah, for us, smart controllers have been a huge initiative for us, for the past 10 years. And on our properties, as I mentioned, most of them do have multiple controllers drawing from a single point of connection. And if you have a smart controller that doesn't have flow management capabilities, your life is going to pretty much be a nightmare, because that controller is changing its schedule every day. And if you're trying to avoid having one controller overlap into another, you're going to run into going past your watering window, and really flow management on a smart controller that's being used on a site with multiple controllers off of a single POC. I mean, there's really no other great approach to it. So it's definitely a must.
Now, Brian, this was one that you wanted to add, and I personally feel as a maintenance professional that I missed out on the entire generation of remotes, because when I was doing maintenance, we didn't have low-cost, affordable handheld remotes like the Roam XL that you see here. Central control was done back at the computer in the office at San Diego State. My estates, I was driving around in golf carts. What can remotes do to make your life easier, and why should they be specified on the plans as a legend item in the plan?
It truly, just efficiency wise, it absolutely probably allows irrigation techs 10 times the efficiency having a remote instead of having 2 people do it and running back and forth. And then having the proper antennas so that when you get down into some of the sites with canyons and stuff, you could have issues with communication. But for us, it's absolutely critical in being able to manage sites.
And central control, again, that's a whole nother conversation in and of itself, but Hunter has 2 different central control platforms currently, actually 3, our legacy IMMS system, the HydroWise system, which a lot of our residential and light commercial customers are using, and then of course Centralis, which is more of a full-blown platform for your more sophisticated controllers like the ICCs and ACC2. So what's your take on central control? And Eric, you can feel free to chime in here as we kind of round this out.
Yeah, I mean, central control is, now we have cloud connectivity is, for a maintenance contractor, where you get the controller adjusting its schedule on a regular basis, using remote weather information, which has now become pretty accurate. And then having also visibility into your controller remotely is just a tremendous advantage from a water management perspective. The days of having to drive to the controller and change that schedule, and that only happening 4 times a year is, the technology we have available now is pretty incredible.
Yeah, I know it's kind of a must-have, but particularly if you're bidding a job, I guess that probably goes into consideration as to as to how whether it has central control or not, as to how efficiently you're going to be able to manage and fuel costs to getting back and forth to the site and all that. So I wanted to close this out with two things, and this is what I have found to be the most important aspect of my job is to make sure that our customers, both from the design team and the maintenance frontline staff, have field support. People think about warranty. A lot of Hunter products have 5-year warranties on commercial products, shorter warranties on other things. But you think about a warranty, but you don't think about who could help me if a problem does arise. And Hunter has a great field support team, and that is really the foundation of what has made us successful in things like 2-wire and more advanced control systems, even Wi-Fi troubleshooting, with newer controllers. And then, of course, the bilingual technical support, the bilingual tech support in our call center at Hunter Industries, 800-733-2823. Again, 800-733-2823. That is the number for our technical services department, and they are phenomenal. 6 a.m. to 4 p.m. Pacific time, and extended hours in the summer. So other things, are training videos that you can go to on the web, on YouTube. That's my go-to if I need to do anything, even now a car repair. I'm YouTubing it before I go out and try and tackle it. It's a great thing for account managers to do. It's a great thing for specifiers to do when they get called if they think there's a problem. Okay, where's my YouTube video? And of course, Greg's going to touch on our Hunter Industries training site. So, Brian, did you have anything you wanted to add to experiences we've shared with regard to field service?
Chris, I would just say that it is critical, and it's been, for me, it's been great that I've been able to have a relationship with you and Hunter, and be able to call when we needed help. And 90% of the time it was us. It wasn't the product, but your support and the training videos, especially now with what's going on in the country and the social distancing, the training videos are critical for us to continue to train our teams.
Yeah, well, it was not kind of you to say, but anyway, that was a paid endorsement also. I'm just kidding. You do have field service nationwide at Hunter Industries. Now, in fact, worldwide, we've got a global support network of field technical representatives. So if you are calling in from the Middle East, I think there are a few on the call, international. We do have international field support, not just if you're local to Hunter Industries. So please feel free to reach out. You can get to it through that call center phone number as your first line of defense. And then if you do need additional training or resources, we're here to help. And Greg, you're going to round us out. With that being said, on our on maintenance standards and some things that maintenance professionals look for, and then how what a professional is certified.
Yeah, so routine maintenance, I think, is one of the biggest things that we can do, and it's annual system evaluations, and that can be anywhere from just going out and doing a quick checklist on site, or actually doing a full-blown audit and throwing down catchment devices and figuring out what the distribution uniformity is and how it's changed over the year. Nozzles, even though they're great, they do decay over time, or they do get buildup of debris on them. So it's really important to make sure that your system hasn't degraded And if it has, do that routine maintenance that gets it back up to par. And then monthly wet checks. I know that it's not in everyone's budget to do this monthly, but it's also not in your customer's budget to pay for something that we didn't catch soon enough. And that can be a mainline break, that can be missing nozzles, that can be a cracked or broken lateral line. These things cost money, and so getting ahead of the ball game and making your customers aware of these before it costs them a lot of money is important. So consider adding that into a monthly schedule. Again, straighten heads. A tilted head can cause poor distribution uniformity, poor coverage. Really important to make sure that heads are straightened and they're not sunken, causing obstructions like the grass being in front of the sprinkler or it being sunken in the ground and a plant has overgrown the sprinkler. Those are things to look at during those monthly checks. Now, if it is sunken, and this happens when stuff gets overwatered, or if there's a heavy rain and we go out and we do our maintenance and we mow the lawn, oftentimes those lawnmowers are going to sink those heads into the ground if they run over it. So it will need some maintenance to pull that back up. So replace appropriate nozzles. And this goes for rotors when you're trying to get a match precipitation rate across the zone. If you're taking over a site, check those nozzles. If you have corners, fulls, and halves on the same zone and they all have the same nozzle, you're not match precip. So you want to check those things when you take over a site to make sure that you have the best coverage and distribution uniformity possible. Now, also checking drip tubing for kinks and breaks. Again, these are little things, but go through the system and look for any water spraying up and make sure that your indicator is coming on. So if you have an indicator on site and the station turns on, you know it's on. Now walk that zone to make sure that there's not any pooling, any sprays. Oftentimes the tubing can get nicked or cut during annual plantings and things like that. So always check back after you do any planting or maintenance to make sure that that irrigation is still good to go.
Yes, and Hunter does have a great irrigation evaluation checklist that you can do that kind of takes us to the next level. So if you're interested in that, please email us after the presentation. Be happy to provide that to you. And again, we didn't want Brightview to have to give up all their secret sauce in this portion of it, because I know they have their own techniques as a professional maintenance provider as well.
And we don't want to scare you out of going out and checking the site. Make a basic maintenance checklist that your service technicians can take out in the field and do. Teach them how to look for certain things. So it may be a one-time thing that you do with each of your lead crew members, or maybe it's, you know, make sure that you have that checklist. And even as a designer, if you think you have a good checklist, provide that to the maintenance company that's going to be taking over the installation after construction, because then they know what to look for and that's what you can expect them to look for. So one of the things I want to mention is hiring certified professionals. And the Irrigation Association has a lot of certifications. And if you look at probably Brian's title and Chris's title and anybody else's titles, there's a few accolades next to their name that give you an insight to what the Irrigation Association has to offer. Also, the CLCA, ASLA, all of these organizations, NALP, are great resources for getting certifications and also hiring qualified, certified professionals in the field. So the QUEL, Qualified Water Efficient Landscaper, is another one that is commonly used for water audits. And the CLIA, the Certified Landscape Irrigation Auditor, are two that qualify you to be a certified auditor for MWELA requirements. Sorry for the child screaming in the background, it's not mine. This will take us out. If you guys have anything else to add before we get into a Q&A session, I'm happy to take any comments from you guys.
I think you did a great job rounding us out. And you know, if there's any questions specifically for our panel that anybody would like, I know we went over on time. It's kind of a heavy topic to get through, but if there are any other questions, we'd be happy to take them. Greg, if you could take a look at a chat box.
Got a lot of great questions here, and you guys did a fantastic job. I don't want to overshadow that. You guys really killed it with that presentation. Brian, Eric, Nick, Chris. Great job. Let's get into the questions. Our first question from Alvin is, on an as-built plan, do you show installed mainline locations?
I'm going to let the panels answer.
Yeah,
that would
go
be
ahead.
best if you did with measurements. It certainly would help find it later on.
Yeah, I agree with measurements, reference points from hardscapes. But yeah, so again, we're not on the construction side, we're on the maintenance side. But yeah, that's the expectation when we get those as-builts, that the main line is really important to be shown on there.
And that's that critical interface between installation and specification. And, you know, being out there for the construction admin and observation of the process is that you're getting that feedback. You're seeing things change. You're documenting these things, and then they make their way back onto those as-built plans. So yes, absolutely.
Fair enough. Here's a two-parter from Alan. We always try to get construction admin, but it's often the first deleted by the developer. How can Brightview and Hunter help to improve this aspect?
Yeah, that's a really good question. I don't know if I have an answer to that, but the one thing that is kind of a saving grace here in California has been the MWILO water audit requirement. So at some point, hopefully the auditor that is coming out to assess the system is going back and providing a list of things that were deficient. And I think that does kind of catch, because that's a really great point. I mean, that happens all the time when costs are being reviewed. The final inspection is something that does get cut out. But I think that's why MWILO recognized it is important for a system to be audited before that permit's signed off.
You know, from the specification side, there's going to be, or there should be, mandatory times where you should be out on site for the installation of trees. They're crane loading palms over a building or whatever that might be. But at that time, you aren't just going out for that. You're observant to everything else that's out there, and maybe you're doubling down on, hey, I'm going out to see palms, but while I'm out there, I'm going to coordinate and take a view at, you know, the mainline installation and then document some of that stuff. So I'm very familiar with that value engineering of the CA budget and it getting whittled down, often the smallest part of the contract. But if you can just build in some mandatory on-sites for things like, you know, big number items, that's when I would just double it down and couple it up.
Answered the second part to that, and the second part of the question was, we also require as-builts to be maintained daily on site. But again, the landscape and irrigation install folks often wait until the end where it's too late and they submit plans that aren't really accurate. And I mean, I can attest to this. I used to do landscape installation inspections, and I'd ask to see, you know, where they were at with the as-builts on the project that's already been completed. And most of the time the answer was, as-builts? Oh yeah, we're gonna do that at the end. And you guys can chime in on this, but I know that that's probably not what you recommend.
Yeah, no, I definitely agree. And it is a challenge. That's a great point that's brought up. I think if you're able to survey most installing contractors, you'd find 99% of them prefer to do it at the end. But hopefully the guy who's coming back to do them at the end, you'll find that most foremen do have a pretty good recollection of exactly where they ran things. And we've had jobs where we've asked the installer to come out 2 years after the fact, and surprisingly, those guys know, you know, they have a lot of information that's locked up top, and it's just a matter of getting them to take the time to put it on paper where it is really helpful. That is, that's the hard part.
I mean, I completely agree with that. And this is another point that gets brought up. Like, is there a way that we can better manage the as-builts after they leave the site? And Michelle had a suggestion that to be able to better preserve those as-builts for future generations and to be able to update them later, including them as a DWG file or a PDF that can be maintained with the CDs, the original CDs. You guys agree with that?
Yeah,
Absolutely. It's about finding the clearinghouse or the place that stores all that. And that gets back to the point that we talked about earlier on, is that if you're driving by a site and you had worked on it and there's a new maintenance company out there trying to facilitate that information through, you know, a printable PDF or whatever it might be. But that's spot on, Michelle. Good point.
Alrighty. And Barbara works with designers, irrigation designers, to do the irrigation plans for her landscape designs. So do you think it's important to indicate which zones they want to see on the plans to be irrigated, or rely on the irrigation designer to know the plants and zone correctly?
Is that from a runtime standpoint, Greg?
For zoning, you get a set of landscape plans and it's just a bunch of plants, and you are assuming that the irrigation designer is going to know what the plant water requirement is to zone those properly.
Sounds like we need to do another webinar with an irrigation consultant. I don't know if I'd care to speculate on that, but I think there is a lot that gets lost in translation. And so trying to group for exposures to your building and just trying to be on the front end of that. I've sat in on some other webinars that irrigation consultants have said, hey, if you could just at least group your plants in planter areas by hydrozone so that we can get a rough guess of what it is, because you don't want to go midway through a hydrozone or have your trees be high water use and your ground cover be low water use, or vice versa. You want to try and match that up wherever you can on your planting plan, and I think that's just best practice.
Yeah, and Eric, this next question, Eric and Brian, I'm going to let you take a crack at this one. This is something we dealt with a lot years back, and that's living in an area with drought. We can only irrigate 1 day per week or whatever when drought restrictions get critical. How do you deal with that?
Yeah, that's, from my perspective, that's really where flow management capabilities come into play, and you're able to maximize that water window. And I think I mentioned this, you can try to be creative by running drip and bubblers during the day outside of those windows, unless you're in a water district that has automated meter readings. But yeah, being able to maximize that water window is really where flow management comes into play. And yeah, let's face it, we're going to have to deficit water. And our approach when we did have a drought, and Brian may want to share some of the ways that he dealt with it. But it was having conversations with customers about the water window not being long enough and which areas we were going to decide to let go unirrigated. And fortunately, we're having some of those similar conversations now with COVID-19 in the economic situation we're in, where customers are coming to us saying, you know what, we're going to let the stuff in the back 40 go. Let's keep the high cost plant material, our high visibility areas watered. Everything else, we're going to try to minimize our utility costs as much as possible.
But it really comes down to how your system was designed hydraulically to begin with. I think, and oftentimes your design capacity is given and that's what you have to work with. So you're trying to design a system that you're going to be irrigating, 4 to 5 days out of the week. And then when you're restricted to 1 day a week, you didn't design for that. So really there's no way you can overtax your system to accommodate that need too. So that becomes another difficult aspect of it, I think.
There's a point in there, Greg, about I know for California and Model Water Efficient Landscape Ordinance, they require mulch and a certain amount of mulch. And when you think about that 1 day that you might get in a deficit situation, is that the importance that mulch plays on locking in the moisture and kind of protecting it from that ET. So that's really what I've found. That might get you an extra day and a half of water if you factor that in.
Good point. And it covers up the drip when it's on the surface, right? This question is, is there a tremendous cost to scratching drip into the surface about 2 inches? I guess, Brian, Eric, you could probably take that one.
At the beginning, at install, no, but later on, as the root zones fill out and start covering that tubing and start pinching that tubing when it's underground, we see trees that have just decimated whole drip systems because they've pinched it all off. So, yeah, overall, I would rather, for ease of maintenance, I would rather see it on the surface where we can just cover it with mulch and it's easily accessible to fix and address.
Okay. And if you were to bury it, do you have a depth you recommend in the situations that you do?
2 inches for me would be okay. And, once you get any deeper than that, and then you have a rodent chew through it and bite it, then you have a problem trying to locate it and fix those.
Okay. Well, this is more of a kind of question suggestion, but in the city of Sacramento, apparently they require 2 4-foot quarter pop-up spray heads for tree irrigation. Have you guys dealt with that at all?
2 4-foot quarter. Yeah, so essentially we're applying overhead irrigation over the root ball, and hopefully with spray heads, you're getting pretty good uniformity. I kind of like that a little bit more than I do the deep root watering, because that water is infiltrating down across the root ball. But I guess if I had to pick, I'd prefer either a bubbler or stream bubbler.
Okay. And then if you were
to that point,
sorry, go ahead.
No, just to that point, Greg, is that if you did have 2 pop-up bubblers that were there, and you were to modify your system as the tree grew, you could easily put a different radius spray nozzle on and face them away from the tree and get that root zone as it creeps out. So that's a pretty versatile approach. And to the point of that being in Sacramento, I think you're going to see it vary in different jurisdictions, but everybody's being a little more progressive, and some people are seeing different success out there. So that's a great share, by the way, on the chat.
That's a good suggestion.
And it is really important to address your tree irrigation, because typically your tree is your most high value asset in any landscape. And down the road, when we get into drought conditions and those fruit balls and those canopies are much larger, your drip line has changed significantly. So having some sort of a tap or place to tap off of that's dedicated, that's not related to all the other heads in your watering planter area, that you could at least tap off of is just a really good best practice if you don't already have it mandatory in your region.
This question kind of follows up with the tree watering from our friend Aaron. With tree rings, do you ever run into disruptive surface roots in the long run? Using like a tree ring on surface method, do you get those disruptive surface roots?
Yeah, no, you do run into it. But I think Brian had mentioned, if it's above the surface, below the mulch, I guess the chances of that root growing up above the soil and then up above and across the drip tubing is less likely if it's above grade than being 2 inches below grade. But yeah, that is one of the challenges.
So do you find that like a longer, less often run cycle might encourage deeper root growth and avoid some of those surface roots?
Yep, that would definitely be one management technique to help avoid that.
Okay. And then here's our last question. We'll end with this one. This is concerning drip. Does fertigation affect or clog the drip emitters?
I don't know, Brian, if you have a perspective on this, but if the fertigation system is used properly, I don't think you'll run into issues with product clogging emitters. But with that being said, I've been on projects where the wrong product was installed in the tank, or it was allowed to solidify because it wasn't run at the proper flow rate, or it wasn't run quick enough, and we did have product solidify. So that is a concern. Brian, you probably have more experience with fertigation in your area than I do.
Yeah, that is, you have to keep using them. You know, if they sit all, you know, a season, when you turn down the systems in the winter and you let them sit, if you got to put something in there just to keep something in the system so that when you go to run it, nothing's hardened. But that would be the general, use the products that are designed for those systems.
Yeah, and with drip, even in Las Vegas, what we'll see is calcification and clogging of emitters, but there are products. So even just water hardness will clog emitters if the water is extremely hard, and it just allows to dry out. But yeah, there are products that you can use to prevent that from happening.
Yeah, and we talked about that a little bit in our point of connection last week, which is an injector system, not maybe just for fertilizer. Some of the injector systems you can run acid, through the system to mitigate some calcium buildup and maybe even clean some of your emitters. So there are various products that you can put through an injector system, for critter control or odor control and various other things in addition to fertilizers. So it's just kind of a new technology. I think that we wanted to kind of to bring up because Brightview is starting to see it more on some of their more progressive high performance projects. Well, Greg, thank you so much. Boy, to our panelists, Eric Santos, Brian Maynard, thank you guys so much for your time today. And going into overtime, we owe you big.
Absolutely. And lastly, I just want to make a quick reference back to the training site, training.hunterindustries.com, if you want more training. And this is where a copy of this presentation will be residing. And as well, check out the YouTube channel and our Rev It Up promotion. That being said, again, thank you all for joining us, and thank you to our panelists and presenters for giving us some really valuable information that we can take away and use in our day-to-day right after this. So thank you all again. Stay safe, stay healthy, and from the bottom of our hearts, thank you for your business and thanks for supporting Hunter Industries.